Dear students, let us see the next question in the subject of electronic and measurements. And this is Dr. Madhuri Gumineni. Design and evaluate a real-time measurement system for industrial application. So whenever we consider a real-time measurement system, there will be a repeated steps will be there. That's why we will call it as a process. So we will see a real-time measurement system. For this, the choice is given to us. And second thing is, next one, quantitatively discuss the dynamic characteristics. So whenever we are talking about a real-time measurement system, there will be rapid changes taking place in a real time. So it is not a static thing. So it is a dynamic. So here the dynamic characteristics are very important, and how it will show an impact in the industry. That is also they're expecting us to give the detailed explanation about it. Explain how these characteristics will impact the system performance in industrial scenario. Okay, let us see. So if you see the real-time measurement system, let us consider one example, flow measurement in a particular industry. So in a chemical process, let us say, a flow sensor, it is used to measure the flow rate. So electromagnetic type of flow sensor we can choose, or ultrasonic type. And next comes the signal conditioning, sometimes to reduce the noise or sometimes to amplify the signal. So based on the requirement, the signal conditioning will do. And then the signal will be connected, given to the A to D converter. Here the conversion takes place and it is converted into digital form. Later, further processing will be done by the microcontroller. And then the control action will be given based on the decision given by the processing unit. So here, what are the dynamic parameters and how it will have an impact on the industry? So first thing, what are the dynamic characteristics? First parameter in this is speed of response. If the sensor, it is the ability of the sensor. If the sensor can able to sense the rapid changes, it can detect the changes fastly, then definitely the response will be very high. So the speed of response will be high. If the flow rate changes at 100 liters, for example, to 200 liters per minute, the system must quickly expected to respond to the changes. And it should update the values on the monitor. If at all, if it is not able to do that based on the sensor problem, if at all there is a problem in the sensor, that will lead to system failure. So entire system will depend upon the sensor performance. That's why the system failure will be based on the speed of response or the sensor performance. And next thing, if at all, in the chemical processing plant, if there is a speed of response is very low, that means a delay is detecting, that leads to a maximum error, or sometimes it causes to accident also. So first parameter we have discussed. Next comes the fidelity. So without any distortion or without any delay, if it is able to produce the values, measuring and producing the value, then it is called a fidelity. Fidelity refers to how accurate the system follows the actual variations. So coming to this, if at all due to pump adjustment, then generally the flow rate will fluctuate. Then the system should accurately represent these variations, whether slowly varying or fastly varying, how it is varying, that it should present in the readings. If at all there is low fidelities, then what happens? So incorrect flow control actions will take place. If there is low control actions, low quality will be there, inefficient operations will be there. So these are the problems in the, if there is a problem in the fidelity. Next comes the lag. What actually means lag? It's nothing but the time delay. Okay, time delay, why it occurs generally? So we are giving the signal to the processing unit. Before giving to the processing unit, we will do the conversion. So while the sensor sends it, and after that conversion takes place, and the microcontroller will depends upon the input coming from the digital. If there is a lag in the sensor and the analog to digital conversion, the decision taking place by the microcontroller will also varies. Therefore, there will be a lag. If there is lag like this, we are considering a chemical or a power plant, the boiler's heat control, if it affects the boiler's heat control, and overheating will take place. So sometimes we cannot control the system also if it goes out of the range due to the lag. So these are problems due to the lag. Next comes the dynamic error. It is a difference between the actual flow rate and the measured value. So how this dynamic will have an impact means, for example, currently if it is within a fraction of a second, if a suddenly flow rate increases and it is not able to momentarily catch up the flow rate and it is displaying that one, then this will have an effect on the refining process generally. If it refining process లో ఏమవుతుందంటే అప్డేట్ ఇన్ఫర్మేషన్ అనేది ఉండాలి. అప్డేట్ రాకుండా లేట్ డెసిషన్స్, లేట్ రీడింగ్స్ వస్తే ఇన్ఎఫిషియన్సీ వస్తుంది. అండ్ సమ్టైమ్స్ ఇన్ కెమికల్ ఫ్యాక్టరీ, in chemical industries or in some type of industries, safety hazards is also lead to some dangerous situations. So these are the 4 parameters that we need to into account. This will affect the system performance. So thank you, students.